Right, so let's have a look for the first question. We have here, we are looking for the exact value. Okay, so highlight the keyword exact value for the integration of this particular expression. Give your answer in this form, where a and b are integers. Alright, so your final answer should be in this particular pattern and your a, b should be integers. Right, so when you want to integrate anything that is related to ln, any ln function, we actually cannot integrate directly. So once we look at the ln in our syllabus, most of the time, we are going to use the integration by part, okay, to apply it. Alright, so what's the general formula for integration by part here? So this is what we have. If I want to integrate u dv, okay, it is equals to uv minus v du. Alright, so I simplify the formula provided in the formula booklet into this version. Right, so if we have a look in our table, list MF19, right? Basically, integration by part formula is provided. Just that it looks a bit complicated. Let's have a look here. Where is it? Yeah, it is this part, this one. Alright, so for me personally, what I do is that I just cancel off the dx and the dx. So I'm having integrate u dv equals to uv minus v du. Alright, yeah. So this is what we have. And then we are going to apply this integration by part formula in our question here. But before we can apply it, right, we basically have a simple rule that we need to decide, yeah, because in the question itself, this is the question. This is the question. And then there are two parts of the question. The first part is u. The first part is u. And then the remaining part will be integration of dv. Okay, so they come in two items, or maybe two parts, I would say. So one part is u, another part is integration of dv. So before you can start the process, right, what we need to do is that we need to decide which one is the u and which one is the integration of dv first. So we need to basically follow a rule that we call as Liat rule, L-I-A-T-E. Okay, just to recall back, yeah. So what is the L here? L means logarithmic function, such as log, ln. Alright, so I means inverse trigo. In our syllabus, in paper 3, there's only one inverse trigo so far, which is the tangent inverse. Then for A is algebra. All the polynomial number are all algebra, such as x squared, 3, 3x squared, all this. Then T means trigo. And also E means exponential function. Alright, so if your group is higher, then it will be the U. If your group is lower, then it will be the integration of dv. Okay, alright, so let's have a look for our question here. We are having ln 3x dx. So if I try to visualize or try to investigate or analyze this one, yeah, ln 3x is one item, and then I'm having a 1 multiplied with ln 3x. So the remaining is integrate 1 dx. So you'll see, the ln here basically is a log function L. And then the 1 here basically is algebra A. Okay, so if you compare these two groups, which group is actually at higher? So it will be actually the L is on top, right? Then the A algebra is lower compared with the L, the log function. So from here, I know that my U should be equals to ln 3x. And after that, the remaining part of my integration here will be the integration of dv. So integration of dv equals to the remaining integrate 1 dx. The dv here actually there's a 1 also, right? Okay. Then now, after you decide which group belongs to which one, then you can start the process of integration by part. First of all, for this particular expression, let us differentiate it first with respect to x. So du over dx, differentiate the ln. 3x, you bring the 3x down, become denominator. Differentiate the 3x, you get the 3, right? Have to multiply it with the 3. After you simplify, you will be having du dx is 1 over x. Right, so du dx is 1 over x. And therefore, if I want to rephrase it further, then I'm having du equals to 1 over x dx. Alright, then how about for this particular part here? Integrate 1 dv, you have a v. integrate 1 dx, you have a x. It is a very simple integration. All right. Then you'll see that for this part, I so far didn't put in the plus c yet because I want to substitute all this into my formula later. Then only I include the constant term in my integration. Okay, so after I decide already, so let's start, yeah? So we start the question here. I'm having ln 3x dx. This is the question, and I want to apply my formula here. So look at the right-hand side, I'm having uv. What is the u? U is ln 3x, v is the x. So I multiply the x with ln 3x, and I have to put a square bracket so that I can put in the limit 2 and 1. Then minus integrate v du. Integrate means integrate, you copy the limit for the original question. V, where is the v here? V is the x. Then where is the du? So let's have a look for du. Du, you can get it from this part. And it is equals to 1 over x multiplied with dx. So you're having 1 over x, then multiply with dx. Alright, so you just apply the formula directly according to what we have here under the u and also the v. Okay, then you can simplify all the equation here slowly. Put the 2 inside, you're having 2 ln 6. Put the 1 inside, you'll be having 1 ln 3. Okay, then minus, and you want to integrate this particular term here. Before integration, please simplify first. We are having integration of 1 dx. Right, then I need to continue to complete this one, the integration part here. Then before that, maybe I can simplify the terms here also. 2 ln 6, right? If you have a look for our final answer, they are requesting us with 1 ln only, ln b, and there's no value in front of the ln. So what I want to do here is I try to simplify first. Try to put the 2, go back to the 6, make it become the power. So you're having 6 squared. So 6 squared is 26. Oh, sorry, 6 squared is 36. Right. Okay, so 2, you put it back, become 6 power of 2. So you're having 36 here, then minus ln 3. Okay, for the integration term here, you just try to integrate. It is a simple integration as well. It should be x, then put in the limit 2 and 1. Okay, simplify this particular term. Ln b minus ln a. What do you get? You're having ln b divided by the a. Then minus 2 minus 1. Okay, so just to recall, I'm having this ln b minus ln a can be written as ln b over a. This is something that we learned previously about the property of the log function. Then this is quite simple, you just simplified it. Then after that, if you rephrase everything nicely, you'll be having negative 1 plus ln 12. And just double check your final answer and see whether it fulfills the requirement of the question or not. So they want us to put our answer in the exact form, and the pattern is a plus ln b, right? So a is negative 1, b is a 12, and both a and b are integer. So that means very likely our answer should be a correct answer. Okay, yeah, so this is how we apply the integration by part, and I hope that you can understand. Right, so this is how we solve question number 1. Alright, so question number 2. Show that the equation of this can be written as a quadratic equation in x. If you want to make it into quadratic equation in x, very likely we need to get rid of the log base 4 first. Then only we can rephrase it become a quadratic equation. Right. So let's recall a few important properties in this part so that you can get the answer. So first of all, you need to recall back how are we going to simplify the value if let's say I'm having log a with the number b equals to x. If you want to get rid of the log, then basically is you have to bring the a to the other side. A is the base number of the log, then with the x become the power. Right, so it will become b equals to a power x. So this is one of it that we are going to apply it soon. And after that, what else do we need to apply is this one. Let's say I'm having log b. Maybe I put it as log better lah. Right. So I'm having log b minus log a. I think we did this in the previous question also, in question number 1. Simplified, right? So you can combine them, become one single log with b divided by a. All right. And after that, what else we need to do is, let's say you're having a number n log x. You can further simplify by pulling the number become the power of the value in the log. So you're having log x power n. Yeah, these are the important properties that we are going to apply soon in this question so that we can express it into a quadratic equation. All right, so let's start with the question first. Okay, so first of all, I prefer to group all the log together. So I bring this particular log to the other side, become minus, and therefore I'm having log 4, then 2x plus 1, then minus 2 log 4, 3x minus 1 equals to negative 2. And like what I told you just now, I don't like the 2 in front of the log, so I pull it back, become the power first, so that I can further simplify them later. All right, so put it back. So what do we have here is you're having log 4, then 3x minus 1, the 2 will become the power, right? Okay, then what is next? You're having 2 log here. I group all the log to one side because of I want to group them, become a single log before I can move all the base number to the other side. Okay, since I already have 2 log on the left, let's combine them, become one single log. So I'm having log b minus log a. What am I having here is it will become log b over a. So I copy the log 4. Then this is my b, 2x plus 1 is the b in this case, and then divided by a. Your a will be 3x minus 1 squared. Then equals to negative 2. When you are having a single log on the left hand side, you can get rid of the log by making the base power to right hand side and keep the number here on the right become the power. Therefore, what do I have here is I'm having a log base 4, right? Okay, so the log with base 4. Therefore, I want to put it become 4 power negative 2. I'm applying this particular part here. This is how I get rid of the log before I can express my equation into a quadratic form equation, right? And next, this looks so complicated, right? Okay, so I try to get rid of all the denominator at both sides. Okay, what I do here, I put 16 to the other side. Then 3x minus 1 squared to the other side. So from here, I think it is quite obvious already. I believe that if you try to expand both sides and rephrase your equation, you will get the quadratic equation very easily, right? So let's expand them first, then group all the terms at one side. Yeah, so we successfully get the quadratic equation here. So this is a quadratic equation. All right, I don't think that we can further simplify anymore. All right, then let's continue further. Now they want you to solve this particular equation. Compare this equation and what we have on top, they are the same. And we have successfully rearranged it become a quadratic equation, right? So to solve for the equation, you need to find the x. Just solve it from the quadratic equation. We cannot factorize this question. So what are we going to do is we have to use the quadratic formula. Right? So what's the quadratic formula? So remember, this is in AS1. So remember or not? So negative b plus minus square root b squared minus 4ac over 2a. Right? Yeah. So let's continue from this part where you are having negative b. b is 38, right? Negative 38 plus minus b squared minus 4ac. So negative 38 squared minus 4. A is a 9. C is negative 15. And divided by 2a. Just in case for those who have already forgotten what you learned before, 9 is the coefficient of x squared, which is the a. Then negative 38 is the coefficient of x, which is the b. Then c will be the negative 15, the constant term. Right. Yeah. So after you get the answer from this part, Then we try to simplify it. You're having two values here. One value that you get should be 4.59. Another value that you get should be negative 0.363. So among the two values that we get now, we have to ignore the negative x here. In this case, it is because of if you try to substitute this negative value of the x inside this particular log, you'll see that it is a log base 4 with a negative value inside. Any negative value in the log will give you a math error. Let's say log negative 2 is a math error. Okay, log negative 5 is a math error. So if you substitute this value inside it, you will get a math error. Right? Same thing happens for this one also. That's the reason why you have to ignore it. Then you try again to test using x equals to 4.59. Substitute it into the both log function here, and you realize that it will give you a certain value, which is not a math error. So that means we only accept this particular answer here. Right, so this is how we answer question number 2. Question number 3. Express this particular term into the form of r cos x minus alpha, where r should be a positive value and also alpha should be in the first quadrant. Right. Okay, so let's look for this particular question first. Before we can express it into this single form of r cos x minus alpha, we need to try to expand and simplify this term first. X sine x plus 45. Okay. Alright, so this is a compound angle formula. So what do we have for a compound angle formula? Just recall back a bit. Sine A plus B. If I want to expand sine A plus B, you cannot tell me that, oh, I just always expand or make it into sine A plus sine B. This is wrong. This is not correct, alright? Okay, so we are having a compound angle formula where sine A plus B will give you sine A cos B, then plus cos A sine B. I need to express this particular term first, then only I can combine it with the plus cos x and further to rephrase it into this term here. Alright, so let's start first. Okay, I'm having 3, then square root of 2 sine x plus 45 degree plus cos x. Okay, so first step, I expand the sine A plus B. So sine A plus B is what? Sine A cos B. Then plus cos A sine B. Plus cos x. Alright, so next step. You will know the value of cos 45, right? So what's the value for cos 45 here? So cos 45 will give you 1 over sub 2. And try to imagine if you're having 1 over sub 2 here. Okay, maybe I just write it out. Then later only I simplify it. So I'm having 1 over sub 2, then multiply with sine x. Then plus sine 45 also is 1 over sub 2. Then multiply with cos x. Okay, then plus cos x here. Okay, then now I want to substitute this value in and also into the both term in the bracket. Then the sub 2 and sub 2 can be simplified. When I simplify that, I'll be getting 3 sine x, then plus 3 cos x, then plus cos x. Then further simplify that, become 3 sine x plus 4 cos x. Yeah, and this is what I have now. Then what I want to do now is I want to continue to simplify this particular term into this phrase. Alright, so let's recall back how can I get the value for r and also the alpha, and how can I rephrase them. Okay, so if I want to simplify my term into this particular part like this, r cos x minus alpha, which is the cos, you need to make sure that your equation here starting from a cos. As an example, I must be having a cos x plus b sine x, then equals to r cos x minus alpha. If you want to make it become the cos, then you have to rearrange your equation become cos here. Alright, at first, at the beginning. Alright, because it will affect your value of a and b. Okay, alright, so must be a cos now. So they want you to change it become the cos. That means later I want to put the cos x in front. Then there's a certain formula to get the r. So how can we get the r? Basically, it is equals to a square plus b square, square root. Then to get the alpha, it will be the tangent inverse of b over a. So you can see that the sequence here is very important, because if you put the sine x in front and cos x at the back, then your alpha will be different. The angle that you get will be different here. Alright, so please take note that you are aware about this more detail here. Okay, alright, then let's continue. Now I want to express this into this pattern. Right, so what do I have here is 4 cos A plus 3 sine x, then equals to R cos x minus alpha. Okay, I need to find the R and also the alpha. So in this case, our A is a 4, B is a 3. Then let us start. R is equals to square root of what? 4 square plus 3 square. So 4 square plus 3 square. Square root 25, I will get 5 if I'm not mistaken. Yeah, then how about the alpha here? For the alpha, you'll be having tangent inverse B over A. So what is a B? B is a 3. Then A is a 4. Right, so 3 and also the 4. And after you simplify it by right, you should get 36.9. Alright, so 36.9 means that because this is in angle form, angle in degrees, so we put it in one decimal place. Right, this is my alpha. Okay, and after that, let us rewrite our answer again. So what do we have here is your original equation, 3 sub 2 sine x plus 45 plus cos x can be written as 5 cos x minus alpha, 36.9. Okay, so this is what you have for part A in question number 3. Right, then let's continue to part B. For part B, they want you to solve this equation, which is equals to -4. And I want you to observe, yeah, just now in part A, our equation is in terms of x. Can you see that? And now, you are having something with 3 theta, which means that you have to replace all the x by using 3 theta. And we know that this equation can be written as 5 cos x minus 36.9, right? You can directly substitute the result that we have in part A into here to solve it. Right. So what do I have here is I'm having 5 cos. Previously, in the previous question, I'm having the x, so x minus 36.9. But in this case, because our question is 3 theta, no more the x, so I have to replace the x by using the 3 theta. Okay, then equals to what? Equals to -4. Okay, so before you solve it, you'll be having cos 3 theta minus 36.9 equals to -4/5. Okay, and after that, I need to go through all the quadrant to see what is the answer, which quadrant, which answer from which quadrant I need to accept it as a final answer. So before that, I want to have the basic angle first. So to get the basic angle, we are taking cos inverse. All the basic angle must be something in the first quadrant, right? So we need to ignore the negative sign here first. Okay, so we have cos inverse 4/5. And what do I get from this part? I will get basic angle is 36.9. Yeah, so my basic angle is 36.9. So later, when I want to go through all the quadrant, I'm looking for 3 theta minus 36.9. And now I need to figure out what is the quadrant that I need to consider what we need to accept in our solution here. Right, so before that, since we are looking for the answer for 3 theta minus 36.9, right, you need to go through all the quadrant. I need to know what's the range that I need to consider for this particular phrase here. Okay, our final answer is theta, and they said the theta must be between 0 to 180 degree. Okay, alright, not inclusive lah. If I multiply with 3, then this will become 540 degree. Then this will become still a 0. Okay, because we are looking for 3 theta minus 36.9, then we need to continue minus 36.9 degree. So if you take 54 minus 36.9, you have 503.1. Then for this one, you'll be having negative 36.9 degree. Okay, this is the range that we need to consider for your answer of 3 theta minus 36.9. Okay, then besides that, we also need to consider under which quadrant they will give you a positive value. They'll give you the answer that you want. Not the positive value, but the answer that you want. Okay, we are having 4 quadrants, right? First quadrant, everything is positive. Second quadrant, sine positive. Third quadrant, tangent. Then fourth quadrant is cos. In the first quadrant, answer is theta, which is the basic angle. To accept the answer in second quadrant, you take 180 minus basic angle. Third quadrant is 180 plus basic angle. Fourth quadrant, you take 360 minus basic angle. Alright, so let's have a look here. We are looking for cos with a negative value. Can see that? Cos with a negative value. So under what quadrant you should be having cos negative? Right, so let's start with first question here. First quadrant. In first quadrant, cos is positive, so I don't accept the answer from this part. In the second quadrant, cos is positive. Cos is negative because sine positive, then cos is negative. And I want to accept the answer from this part. So for cos negative, how to accept the answer from this part? Your answer should be 180 minus theta. Therefore, what you need to do is that you have to take 180 minus your basic angle. 180 minus your basic angle. Alright? Okay, so your basic angle just now is 36.9, right? Yeah, so you take 180 minus the basic angle. Alright, so what is the answer that you get? You should be having something like 40 something. 49, 49.1 is it? 149.1. Sorry, 143.1. Wait, I don't have calculator with me now, so I have to do something very stupid. Okay, this is a 1, then 3, then 70, so 43.1. Okay, so for second quadrant answer, you should be having 143.1 degree. Okay, and very obvious, this is still in the range, right? Okay, after that, this is the second quadrant. Let us proceed to the third quadrant. So third quadrant, tangent positive, that means cos is negative. We are looking for the answer with cos negative. So that means the answer should be accepted from here in the third quadrant as well. So you have to take 180 plus theta. So you take 180 plus 36.9, and what do you get? You'll be having 216.9. So again, this answer, you are taking 180 plus 36.9. Okay, so you have 216.9. It is still inside the range that we should consider. Okay, all right. Then after that, fourth quadrant, cos is positive, right? I only want to consider the value for cos negative, so I don't accept the answer from this part anymore. Then we need to continue because the range here basically is quite big until 500 something. So we double check again, should we accept the next answer? So the second round, first quadrant, second round, first quadrant, cos is positive. So you don't accept the answer from here. Second round, second quadrant, cos is negative in this part, right? So I have to take the answer from this part. Just now I already take the answer here. So during the second round, we have to add 360 to your answer because it is already like one complete round. Alright, so you add 360 to your first answer from the second quadrant. And what do you have here is you're having 503.1. Okay, then if you try to have a look here, it is just nicely fit the edge, the end of the range given here, 503.1 and 503.1. But please take note that there's no equal sign in this case, no equal sign, which means that 503.1 shouldn't be in your consideration of your final answer. Alright, so that means we can stop here already because if you continue, all the answer that we get is more than 503.1, which is already out of the range. Can you understand what I say or not? Alright, so to get the value of theta, we just need to make sure that we add 36.9 for every single value here. and after that divide it by 3. Alright, so maybe I put it like this first. Okay, so 3 theta plus 36.9 plus 143.1, you should be getting 180. Then 216.9 plus 36.9, you'll be having 253.8. Then of course, for your final answer, kindly divide it by 3. So you will get this answer. Theta equals to 60 and also 84.6. Correct to 1 decimal place for the angle in degree. Right, so this is how we solve question number 3. Question number 4. We are given a diagram and then it shows the graph of e power sine 2x multiplied with cos 4x, and the domain given in this diagram is from 0 until pi over 4 for the x. Then its maximum point is n. So they plot a point here. It is a maximum point for this curve. Right. Find the x coordinate of n. Alright. For this question, they are asking for the x coordinate, which is the maximum point coordinate. So to find out any maximum point or minimum point or stationary point in any equation, we have to apply differentiation. And we let the differentiation dy dx equals to 0. Okay? Alright, so let us start now. If we have a look for this particular equation that we have here, it is basically the product of two functions. We are having e power sine 2x multiplied with cos 4x. So to find the differentiation, I need to apply the product rule. I don't know whether you still remember the product rule. How does it look like or not? Okay, so yeah, if you are having u multiplied with a v, and to get the differentiation, what we do is that you copy the first bracket or first function, differentiate the second, then plus, copy the second function, differentiate the first. Okay, then after that, you let dy dx equals to 0. Then you try to solve it from there and get the coordinate of the x. Okay, all right. Then let's have a look here. Y equals to e power sine 2x multiplied with cos 4x. Okay, so to get the dy dx, what I need to do here is I copy the first bracket first, differentiate the cos 4x. Differentiate cos, you'll be having negative sine 4x. So all these functions here, you need to go and memorize the basic differentiation, the basic integration formula. Please go and memorize it if you can. It will help you to cut short your time a lot. Alright, so differentiate cos, you'll be having negative sine. Then simplify, differentiate the 4x, you get the 4, right? That means you have to multiply with the 4. So this is basically what we have here. Now copy the first function, differentiate the second. Then now I need to copy the second function, differentiate the first. Alright, so differentiate e power sine 2x, e power anything, you just copy it. Then you differentiate the power. Differentiate sine 2x, you get cos 2x. After that, you need to continue to differentiate the 2x, you get a 2. So this is copy the second function, differentiate the first. And after that, we are trying to simplify them first. Negative 4, then e sine 2x, sine 4x, then plus, then what do I have here? 2 e sine 2x cos 4x, then cos 2x. Okay? Yeah, then continue further. We want to let the dy dx equals to 0, right? And this equation looks so complicated. Let us try to factorize out something that we can do first. We can take out first. We can take out basically the 2e power sine 2x. Factorize out this one. So I put this one in front because it is a positive. Then this one negative, I put it at the back. If I take out the 2e power sine 2x, I will have cos 4x, cos 2x for this case. Alright, then what happened here? This one you need to have negative 2 sine 4x. Yeah, alright. Then you're having two parts of the equation here, right? And we can continue to simplify them. So I'm having two equations here. E power sine 2x equals to 0. Then cos 4x, cos 2x. minus 2 sine 4x equals to 0. Okay, this part, if you try to take log both sides or whatsoever, right, you realize that you'll get a math error lah, because ln 0 is a 0. Okay? Sorry, ln 0 is a math error, so you cannot solve it from this part. So you just ignore it. Okay, let's have a look for this particular equation. It looks so complicated as well. So usually for me, right, I will try and figure out whether can I factorize out anything from the trigo part or not. Or maybe can I reduce it into something that I can factorize out or not. Alright, so I realized that for me personally, this is what I think of. I can reduce the sine 4x becomes sine 2x cos 2x. Then I can factorize out the cos 2x from here. Okay, I apply the double angle formula. Alright, so I'm having this minus, it will become 4 sine 2x, then cos 2x equals to 0. Okay, so let me write out the formula that I'm using from here. I'm using this sine 4x can be written as 2 sine 2x and cos 2x. Okay, the original formula actually comes from this one, 2a. Sine 2a equals to 2 sine a cos a. So 2a become a and a. Then now I have 4x ma. So 4x here become sine 2x and cos 2x. This is how I get the step here. Alright, okay, then after that, when I have this equation, I know that I can take out the cos 2x. So it becomes cos 4x minus 4 sine 2x equals to 0. Alright, yeah, then again, this part and this one, I can further simplify that into two equations. I'm having cos 2x equals to 0. Then cos 4x minus 4 sine 2x equals to 0. Alright, let's solve the easier equation first here. Okay, how can I get cos 2x equals to 0? So if you try to imagine the diagram that you have, for your cos graph, this value should be pi over 2. Alright, so 2x is cos inverse 0, you have pi over 2. Then your x is equals to pi over 4. Okay, should I accept this as the final answer for the coordinate of the x? If you are not so sure, let's have a look here, yeah? X is equals to pi over 4. Let's have a look at the diagram here. Where is the pi over 4? This one. For the point that you get just now, basically it denotes this minimum point by right, the stationary point here. Which is not correct because we are looking for this one, not this one, right? So again, although we already get an answer for pi over 4, but this is not the answer that we want. So ignore it again. Let's continue further for the next equation that we have. Then ask yourself again, how can I solve this equation? I'm having sine 2x. How can I change my whole equation become sine, something with sine 2x? Okay, so for cos 4x, there's a double angle formula that I can change it. Okay, so I want to use this one. Cos 2a, there's one formula which is 1 minus 2 sine square a. Okay, this is a double angle formula for cos. So cos 2a equals to 1 minus 2 sine square a. And if you already forget all this, you can always refer back to this MF19. Me personally, I prefer students to memorize it because it will save a lot of your time. When you have all this in your mind, then you know which one need to be applied in a faster way. Alright, I will say. Okay, and now I'm having this one cos 4x. So that means I have to change the 2a become 4x, then the a will become 2x. Then from here, this is what I have. Cos 4x, I can write it become 1 minus 2 sine square 2x. Then minus 4 sine 2x equals to 0. I have my equation in everything in terms of sine 2x. So I rephrase it again. If I rephrase it, this is what I get. I'll get a quadratic form equation in terms of sine 2x. Okay, I hope that you see it. Then let's continue further. To solve for this quadratic equation, I don't think that we can factorize them. Therefore, we have to use the quadratic formula again. I'm not going to write it out here anymore. Yeah, please refer back to the formula booklet. So what do I have here is negative b plus minus square root b squared. So 4 squared minus 4, a is 2, then c is negative 1, divided by 2a, so 2 times 2. Okay, further simplify it, you'll be having negative 4 plus minus square root 24 over 4. Okay, then I'm having negative 2 plus 6 over 2. Another one is negative 2 minus 6 over 2. Okay, then for this part of the answer, I need to ignore it again. Why? Because if you try to press calculator, right, this value itself will give you a value smaller than negative 1. When you want to take sine inverse for any value that's greater than 1 or smaller than negative 1, there's no solution also because the range of the sign is between negative 1 to positive 1, right? So there's no solution if you have any value less than negative 1 or any value greater than positive 1. So ignore this one again, and this is my final steps to go. Alright, so to get the answer here, I need to get the basic angle again, right? Basic angle. So basic angle is sine inverse negative 2 plus square root 6 over 2. This is a positive value. I'll make sure that this is a positive value when you press calculator. I think it is positive value. So your sine inverse will be 0.22668 Okay, and we are looking for the answer sine positive, right? Then it should be in the first quadrant. So what's my answer in the first quadrant? This is the answer, basic angle. So 0.22668 Then you have to simplify it, cut it short into 3 significant figure after you divide by 2. So by right, your x should be equals to 0.113, correct to 3 significant figure. Right, yeah, so it is a bit long, but I hope that you understand the steps that I explained here. Okay, so maybe some students will ask how I know that I need to use this equation or how do I need to use those equations. So basically you have to practice a lot because when you practice a lot, then you have some idea in your mind. Oh, when you solve this question, then what is the process or maybe what is the equation that you can use to continue and solve it. All right, yeah. So it is a long question for this one. I mean the solution is quite long. All right. So I hope that you understand this question. So this is the end of question number 5. There's a shaded region. Oh, they give us the shaded region on the Argand diagram. Show the point representing the complex number Z defined by 2 inequality. Okay, so I think the diagram is quite big. Let's enlarge it a bit. Okay, the shaded region is bounded by a circle and a line parallel to the imaginary axis. So if there's a circle, I think we can see it, right? Then there's a line here, vertical line. The boundaries of the region are included in the shaded region. They want us to find the 2 inequality in terms of Z that define the shaded region. Alright, so first of all, you can see that the shaded region is bounded in the circle. And then what's the general formula that we will have? So it will be modulus Z minus the center of the circle, then less than the radius. Right, when it is bounded by the circle, that means it is less than the radius that we have. Where is the center of this particular point? Of this particular circle? This is what we have. So it should be 1 minus 2i. So Z minus 1 minus 2i smaller than what is the radius here? So the radius is 2 unit, you can see. So smaller equals to 2. Okay. So why there's an equal sign here is because of, in this question, they did mention the boundaries of the region are included. Are included means that the line is a solid line. Okay, it's included, should have the equal sign here, right? In the shaded region. Then after that, what is another inequality that we have? So when I write out this particular inequality, right, it denotes the whole area, this part. Okay, alright. Then after that, how can I write out another inequality so that it is only bounded or restricted to this part only, the shaded area? So you can have a look for this particular line here. For this particular line, it is actually x equals to 2, right? The value of x equals to 2. And what is the value of the x? So when we're having a complex number, z equals to x plus yi. And the x here will be the real z, the real part of z. So that means for this question, you will see that the real part of z should be greater equals to 2. So if you try to combine these two inequality together, the final area that we shape is what they give us here, right? Yeah, so basically this is what we get for first part of the answer. There's no specific step. You just need to look at the diagram provided. Then you need to know what is the basic equation, the inequality that denote the circle and also the straight line. Then just straight away write it down. All right. Okay, so this is what you have for 5a. Then let's have a look for 5b. Calculate the least value of argument z for points in this region. All right, so least value of the argument z. Okay, argument z means that I want to know the argument of z from 0 plus 0i. That means from the origin. I want to know where's the argument of the z, right? Okay, so let us have a look for the diagram again. This diagram will be very useful for us. Okay, right. Maybe for me, I just try to move my answer here. This is the part A. Okay, so this is part A. Then let's continue to part B. The least value of the argument z. Where is the least? Okay, let's talk about the argument z first. So just now I told you that argument z means that the argument that you calculate, that you measure from 0, 0. So as an example, your z must be anywhere in the bounded region, right? Shaded area. Let's say this is your z, yeah? So you need to know that the argument of z means start from 0, 0, draw a line to the z, and this is your argument. This is the argument of z. Let's say your z is here, anywhere in the shaded area, then your argument of z will be, you draw a line first, then your argument of z will be this red color. This is the argument of the z. Okay? Therefore, for this question, they're asking for the least value argument of z. That means the z must be very negative value. Because you can see that all the bounded region is below the x-axis. All the argument that we draw is a negative angle. Alright, so to get the least value means that you need to make sure that the z is lower enough to make sure that you get the most negative argument. So where's the most negative argument? By right, it should be this one. This is the lowest point of the z. Okay, and then starting measuring from 0, 0. If you draw a straight line here, this is the argument. And I don't think that there's any other point of z that can be lower than the z, or can give you the smaller value than this argument. Alright, okay, this is my argument z here. This is my z here, and I want to find this argument. Alright, so to find the argument, right, some students, they will say that, oh, can I try to find out the coordinate? Can. There are many ways. Alright, so I will also tell students, if you want, you can use some properties of triangle in the circle or whatsoever to help you, if you can. Alright, then some students might say that, oh, I want to solve it by finding out the coordinate. Also can. There are many ways. So you have to try and visualize it and try and see which one can give you the answer that you want. Alright, okay, then now, I already know that this is my z that I want to have. I realize that I have one circle and also a vertical line. So it's not too hard for me to find out the coordinate of this particular z here, because z is the intersection point of the vertical line and also the circle. So let's have a look for the equation of the circle first. If I want to put it in the general form of the circle, what do we have here? X. Okay, then negative 2, right? Oh, sorry, my x coordinate for the center is 1, right? So I'm having x minus 1 square. Then plus, my y coordinate for the center is negative 2. Therefore, I'm having y plus 2 square equals to, what is the radius here? The radius here is 2. So it will be 2 squared. So I put it as a first equation. After that, the second equation is the vertical line where I'm having x equals to 2. Then the z, the point z is the intersection point for these two equations, right? So I substitute 2 into 1. Then I try to solve for the y. Okay, so 2 minus 1, you get a 1. 1 square plus y plus 2 square equals to 4. then y plus 2 equals to plus minus square root 3, then y equals to 2 plus minus square root 3. Okay, so you're having two coordinates for the y. One is 2 plus sub 3, one is 2 minus sub 3. Then you need to decide yourself, yeah? Which one do you think that is the correct answer? Okay, so which one is the correct answer here? Alright, so 2 plus sub 3 should be a positive value, right? So 2 plus sub 3, yeah, that means your y coordinate should be positive, which is on top. Okay, so it shouldn't be lah. It should be the negative value. So you should take the 2 minus sub 3. Okay, therefore your z is having the coordinate of 2 and also 2 minus sub 3. Okay, this is the point. And then I want to calculate this angle. So to calculate this angle, I can refer to this particular triangle here. Can you see that? This particular triangle. Okay, so that means the horizontal line here is a 2 unit. Then the vertical line here until the z from x-axis is 2 minus sub 3. So to calculate this angle, so you should know that the tangent theta is y over x, right? Therefore, your argument of z is tangent theta equals to y, which is 2 minus sub 3 over 2. Okay, if I want to know the positive value, then I just ignore the negative sign here. Okay, but no matter how, you can just try and press that. So theta is tangent inverse 2 minus sub 3 over 2. Okay, then by right, you should be getting a negative value because we measure from x-axis in clockwise direction. So you try to press calculator and see, do you able to get a negative value from here? If I'm not mistaken, by right, you should be getting this value, negative 1.08. And this will be your least value of the argument z. Negative 1.08, correct to 3 significant figure. For this question, if you want to keep it in the degree form, also can, no problem at all. Alright, yeah, so this is how we solve question number 6. Solve the quadratic equation in this form. Give your answer in the form of x plus yi, where x and y are real. Right, so for this question, it is a quadratic equation, but it is in a complex number form. Alright, so to get the w by right, you should be getting a complex number as well. They already mentioned here, your w should be x plus yi. Okay, since you are having a quadratic equation, right? Again, we are going to use the quadratic form to solve it, the quadratic formula to solve it. So the coefficient in front of the w square will be the a. The coefficient in front of the w will be the b, and also coefficient in front of the x power 0, or the constant term, will be the c. Okay, so to find out the w, I'm going to apply the formula for quadratic. This is still the same, negative b. So negative 4 plus minus b square minus 4ac. So what is the b square here? 4 square. Minus 4, then a, then c. Divided by 2a. Okay, so first of all, let us try to expand the complex number in the square root. 4 square, I'm having the 16, then 4. 2 times 2 is a 4, plus 2i minus 2i becomes 0, then I'm having negative I squared. Negative I squared is a negative 1, so negative 1 become positive 1. Then divided by 2, then 2 plus I. Okay, then continue further. Simplify the value inside. So 4 plus 1 is a 5. 5 times 4 is 20. 16 minus 20, you have negative 4. Okay, then maybe before I forget, I just help you all to recall a bit, yeah? So what is the meaning for the I? I means square root negative 1. So that means I square is negative 1. Okay, so I simplify the I square just now in this part from here. Okay, where I square should be equal to negative 1. I didn't show it in detail, yeah? This is the step that I apply. Okay, then now let's continue further. I want to simplify square root negative 4. So square root negative 4 can be written as square root 4 multiplied with square root negative 1. Square root 4 multiplied with square root negative 1. So what do you get from here is you're having negative 4 plus minus 2i divided by 2, then 2 plus I. Okay, we almost get the W already, but of course we have to simplify them first. Okay, so I'm having negative 4 plus 2i and also negative 4 minus 2i. For negative 4 plus 2i, if I take out the 2, so I'll be having negative 2 plus I. Then divided by 2 and also 2 plus I. Then for another value, negative 4 minus 2i, I take out the negative 2. Then I'm having 2 plus I divided by 2 with 2 plus I. Okay, so this particular part here, I got negative 1, which is already the answer that cannot be simplified anymore. Alright, then for this one, you can further simplify it. You have to rationalize it to get rid of the 2 plus I in the denominator. So how can I get rid of the 2 plus I in the denominator? You have to rationalize it, right? So by multiplying 2 minus I and also 2 minus I. Okay, then this part you are already having the answer negative 1. Okay, so next let us further simplify this. In the numerator, what do I have? So for the numerator here, I'm having 2 times 2 is a 4. 2i minus 2i becomes 0. Then negative I squared becomes positive 1. Negative 2 times 2, you get negative 4. Negative 2 times negative I, you have positive 2i. Then positive 2i. Then negative I squared, you get a positive 1. Okay, then further simplify from here, I group all the pure number together. So negative 4 plus 1 is a negative 3, right? So negative 3 divided by 5. So you're having negative 3 over 5. Then for the imaginary part, 2i plus 2i is a 4i. 4i divided by 5 and you're having 4 over 5i. Okay, you successfully get rid of the denominator with the I. And by right, this is your final answer for the W. So your W will have two possible values. One of them is the complex number and the other one will be the real number. So if you want, you can also write as negative 1 plus 0i if you want to keep it in the complex number form, yeah? Alright, x plus yi. So some students say that, oh, I want to put it as negative 1 plus 0i, can or not? Can. Alright, but of course, it's not wrong that you just put it as negative 1. Okay? Yeah, so this is how we solve question numbers. Alright, so question number 7. We are given the parametric equations of a curve as such, like this. You are having the x in terms of t and also y in terms of t. Then they want us to obtain a simplified expression for dy over dx in terms of t. Alright, so when you're having the parametric equation and you want to find out the dy dx, basically you have to apply you have to apply differentiation separately, and after that apply chain rule to get the dy dx. Alright, so just to recall back here, if let's say you're having any parametric equation, the main idea that we are going to get the dy dx is using the chain rule. So how the chain rule look like? So basically it will be dy dx equals to dy over something multiplied with something over dx. So the something here, right, depends on the variable that you are having in the equation. So for our question here, we are having the variable of x in terms of t, right? And also y in terms of t. Basically, we are going to find out dy dt first and also find the dx dt, then combine them together to get the dy dx. So this is why we have it as a chain rule. Alright, okay, so let's have a look for the x equation first. I'm having x equals to t squared, then minus ln 2t plus 1. Apply differentiation with respect to t, I'm having dx over dt. Alright, so let's have a look for the first term first. The first term here, I'm having t squared. Differentiate the t squared, what we do is we pull the power in front, copy the t, power minus 1. So you're having 2t power 1. How are we going to differentiate the ln 2t plus 1? So the process of differentiating the ln is you are bringing the whole bracket inside the ln, go down, become the denominator. So you're having something over 2t plus 1. And after that, please differentiate the whole bracket here. So differentiate 2t plus 1. What do you get? You have a 2, right? So you are basically having a 2 like this. Okay, so this is my dx dt lah. And because of later, when I want to apply in the chain rule, I need to have dt dx, which means that I have to change the dx dt become dt dx. To make it more convenient later, I will try to combine these two terms become a single term first. So what I want to do is like, how do I combine them? I have to combine these two terms become one fraction. All right, so let's have a look here. So I'm having one fraction here. To make it become one fraction, I must make sure that both of them are having the same denominator. So I'm having 2t plus 1. I have to multiply the 2t with 2t plus 1, right? So that they are having the same denominator, then minus the 2 remain the same. All right, then what do I have here? So I'll be having 4t squared plus 2t, then minus 2 divided by 2t plus 1. So this is the fraction that I'm having for this case. Okay, then after that, what do I have for the equation of y? Right, so let's have a look. Y equals to t over 2t plus 1. Okay, so again, to apply differentiation, in this equation, I will be having dy over dt. Alright, then I will assume that this is a quotient, okay? You're having a fraction, so top and bottom both also have the variable t. I'm going to apply quotient rule. So do you still remember what is the quotient rule? Let's say you're having y equals to u over v. Then the quotient rule will be dy dx will be 1. So what you need to do is like you square the denominator, become v squared. Copy the bottom, the v, divided, multiply with the differentiation of top, which is du dx. Then minus, now you copy the top, differentiate the bottom. So you're having dv over dx. This is what we call as quotient rule. And this formula is provided in the formula booklet. When you want to apply differentiation, right, especially you are having a fraction, then this is one of the rules that you can consider to use it. So I'm going to use this now. Alright, so I have to square the denominator, become 2t plus 1. Copy the denominator, differentiate the top. So differentiate the top means I differentiate the t. Differentiate t, I'll get a 1. Then minus, now I copy the t, but I differentiate the bottom. So differentiate 2t plus 1, you're having a 2, right? So you multiply with the 2. Okay, then again, of course, you need to further simplify it. So I'm having 2t plus 1 minus 2t. Then divided by 2t plus 1 square. And eventually, what do I have here is I'm having 1 over 2t plus 1. Squared, sorry. Okay, so I successfully get the dx dt and also the dy dt, and now I can combine them by using a chain rule. Okay, chain rule to get the dy dx. Alright, so let's start with the chain rule now. Okay, so I just show you the formula here. Okay, dy dx means dy dt multiply with dt dx. Alright, so what do I have here as dy dx? Dy dt. So I just copy down what I have. So I'm having 1 over 2t plus 1 squared. Multiply. Then dt dx. What I have here is dx dt. So if I want to get dt dx, I have to swap it upside down. So I'm having 2t plus 1. Then divided by 4t squared plus 2t, then minus 2. Okay? Then after that, what else can I do here is I can basically simplify the 2t plus 1 on top with the square here. Okay? Alright. And after that, what do I have? Then I don't feel like I want to expand it, but I just want to make it more simple or factorize it. I'm having 2t plus 1. Then for this particular denominator here, what am I going to do is like I can take out the 2, right? If I factorize out the 2, then I will be having 2t squared plus t and minus 1. Okay, continue further. I will be having 1 over 2, then 2t plus 1. Okay, for this quadratic expression, right, you can further factorize it as well into a smaller bracket. So what do we have here? I'm having 2t and the t, then 1 and the 1. I want to have positive 1, right? So this is plus and this is minus. All right. Yeah, so this is basically what we have for the dy dx under the parametric equation. So this is how we solve question number. Okay, we are now at question number 8. Alright, so we are given the variable x and y satisfy the differential equation of this one. Then k is a constant. It is given that y equals to 0, x equals to 0, and also y equals to -1 when x equals to 1. We are given two pieces of information here, which means a pair of x and y. So that means very likely in our solution later, right, there are two constants that I need to find out the value. That's the reason why they give us two set of data here. Okay, two set of value or the pair of x and y here. Right. Okay, they want you to solve the differential equation and find the exact value of y when x equals to 3. Okay, so final answer should be the exact value of y when x equals to 3. Then of course you have to solve the differential equation first, right? Okay, when we are talking about the differential equation in our syllabus, we are having something very basic where all the differential equations are separable. So separable means that you can separate all the variable x to one side and also all the variable y to one side. Okay, so when you're having this as a differential equation, right? Basically, you can see clearly that we're having x and y. So we are going to group all the y at one side. That means I'm going to move the e power 2y to the left. So I'll be having 1 over e power 2y. Then copy the dy. And the rest, I want to bring them to the right hand side. So like x squared plus 1 on the right? I want to bring it over, become divided by x squared plus 1. Something over dx at the left hand side, I want to bring it up to the right hand side as well. So it will become dx at the back. So this is what we call as a separable differential equation. That means you can separate the variable clearly, okay, to each side for the different variables. Okay, all right, so that's always the very first step in our differential equation question. So separate all the variables first. Okay, then after that, try to observe, after you separate them correctly, successfully, then what you do is like you just put the integration sign, and now you need to integrate both sides of the equation. All right, so when you are going to integrate both sides of the equation, let's have a look for some very basic integration technique first. We are going to integrate e power -2y. So just help you to recall a little bit, yeah. How are we going to integrate any e with the power ax? Okay, so for the integration of e power ax, basically we're having e power ax, copy back the original thing. Then you differentiate the power ax. Differentiate ax, you'll get an a, right? So you have to divide by the constant a. And of course, you're having a plus c. Then on the right hand side, what do we have here is we are having a fraction. But this fraction, there's x power 1 on top and then x squared at the denominator. And you need to try to observe the pattern of this particular fraction. It is not hard for you to realize that it is basically referring to f prime x over fx pattern. Okay, so when you're having f prime x on top and also fx at the bottom, when you apply the integration, basically it is ln, then modulus fx plus c. So these are the two basic formula that is provided in the formula booklet. So you need to know how to apply it, right? But before that, of course, you need to observe the pattern of the expression that you have first before you integrate them. Then only you know what is the correct rules or correct formula to be used. Okay, right. So let's start with our integration here. On the left hand side, I'm having e power -2y before the integration, yeah. Okay, I want to make it become this pattern, e power ax. Then on the right hand side, I'll have a k. The k is a constant, right? So I don't want to disturb it when to put it inside the integration. So I will just take it out as a constant outside. I'm having x now. Then I'm having x squared plus 1. Alright, like what I told you earlier, to integrate the fraction, right, this pattern basically referring to f prime x over fx. So now let's have a look for our denominator fx, yeah? So when you're having the denominator fx, you need to make sure that you're having f prime x on top before you integrate it. So let's have a look for our denominator. I'm having x squared plus 1. If you differentiate x squared, what do you have? We're having 2x, right? But do you see any 2x on top? No, there's no 2x here. Therefore, to adjust it to become the f prime x, you need to multiply a 2 here. So you multiply the 2 on numerator, basically you will be having f prime x on top, fx at the bottom. But you cannot just simply multiply the 2, right? Because you already changed the answer for the equation. So what are you going to do is like, when you multiply the 2, at the same time, you have to divide the 2 outside. So I make the 2 as a constant outside. Okay, so although you see that you are multiplying 2, but you also divided 2 at the same time, that means this expression basically remain the same. You didn't do any, you didn't add in any extra value. It is still the same, just that we write out in a different way only. So we are having 2x over x squared plus 1 with k over 2 outside. So that we are having the f prime x over fx on the right hand side. Okay, so after everything is ready, then we start the integration. So e power negative 2y, applying this formula, so you'll be having e power negative 2y divided by the differentiation of the power, where you get a negative 2. Okay, then for k over 2, you just copy it, because for this expression, I know that it is f prime x over fx. So f prime x over fx, you want to integrate it, you'll be having ln fx. Therefore, I will be having ln x squared plus 1 here. And also with a plus c. Okay, and now maybe some of the students will ask, why do I only include the plus c on the right hand side but not on the left? Okay, basically, right, when we are applying any integration, you should actually have a constant on the left and also a constant on the right. Both the left and right hand side constant are not having the same value, might not be having the same value, right? Or always not having the same value. So to make my life easier, right, to make our life easier, usually what we do is that we will assume that we group all the constant to one side. So that means I group them as an overall constant c. Therefore, you didn't see any plus c on the left. Okay, if you want to write out, it should be a plus a here, then you have a plus b here. And then you are having more variable or unknown to find out the value later, which is more complicated. Okay, so that's a reason why we didn't put a plus c after the integration here, but we are assuming that we group all the constant term on the right. Okay, right, then let's continue here. From this equation, you already successfully solved the differential equation, but of course, this is not the particular solution yet. It is just a general solution, because you can see the value of c that we don't know yet, and also the value of k that we also need to find out soon. Okay, how to find the value for c and also the k? Therefore, you need to apply the information that is provided in this question. So the first pair of the information provided is this one. When x equals to 0, y equals to 0. Okay, so let's have a look. When you are having x equals to 0, and also y is equals to 0, what will happen to your equation here? So you'll be having negative 1 over 2. E power negative 0, you get a 1. Agree? Alright, so k over 2 is a constant. I just copy it. When x is equals to 0, so x squared plus 1 is 1. So you're having ln 1. Then plus c. Okay, then for your information, the value of ln 1 is what? Value of ln 1 is a 0. Therefore, what is the value of the c that you get? Your c will be getting this value, which is negative half. Alright, so we successfully get the first piece of the value of the c, and now we need to continue and get the value for k. How can we get the value of the k? And again, we are going to use the second piece of information where y equals to negative half and also x equals to 1. So let's apply it here in our equation. Alright, so before I start, I rewrite my equation again. Yeah, so I'm having negative 1 over 2e power 2y equals to k over 2 ln x squared plus 1. Then the plus c here is negative half because you successfully get the value for plus c just now, right? Okay, then let's continue further. I want to use this value now. X equals to 1, y equals to negative half. So when x is equals to 1, y is equals to negative half, what will happen to your latest equation here? Your latest solution. Okay, so let us substitute the value. We'll be having negative 1 over 2 e power 1. Sorry, is it 2e power 1? Wait, yeah, let me have a look. Yeah, I don't think so, right? You're having 2y. Oh, sorry, 2y. Okay, correct. Okay, so let's have a look again. So 1 over e power 2y, not e power 2x. So 2e power 2y. So 2 multiply with negative half, you are getting the negative 1. That equals to k, you don't know the value, right? Okay, so what's the value for x? It is a 1. So you're having a ln 2 here, then minus half. Okay, then by maybe using the calculator to help you a little bit lah. Alright, or maybe for me, right, usually what I do is like, I try to simplify it first. 1 over 2 e power negative 1. So the e power negative 1 at the bottom. So if I try to simplify it without the negative power, it will become e power 1 over 2. Then I move the half over, become plus half, equals to k over 2 ln 2. Right, then I rewrite my equation again. So to make my equation to be simplified easier, I put it in a single fraction form like this. Then later when I want to move all the values here and there, it's easier. 2, I move it over, cancel off with 2. Ln 2, I move it down, I'll be having 1 minus e power 1 over ln 2. Alright, so all this looks a bit tedious, but basically it is not something very, very complicated and hard. It just looks a bit tedious only. So when you want to simplify all the values, just make sure that you be careful on it. Alright, okay, so from here, I successfully get my final equation like this. So I'm having negative 1 over 2e power 2y equals to half multiply with the k. So your k is 1 minus e power 1 over ln 2. This is the k. Then ln x squared plus 1 minus the half. This is basically the particular solution that we are having here lah. Okay, and is this my final answer? No, not yet. It is not the end of the question yet. So if you refer back to the question again, what they want us to find is, they want you to find exact value. Highlight the keyword exact value when x equals to sub 3. So you need to substitute x equals to sub 3 inside, try to simplify all your value and get the exact value for the y. Exact value means not the decimal number long one, right? So it should be either in a surd form, high form, or fraction. Okay, so when x equals to sub 3, so let's continue for this part. Okay, when x is equals to sub 3, what will happen to this particular equation here? Okay, so let's substitute x equals to sub 3. Okay, I will be having 1 minus e power 1 divided by 2 ln 2, then ln x squared plus 1. So sub 3 squared is a 3. 3 plus 1 is a 4, right? So you're having ln 4, then minus minus half. Okay, yeah, so let's simplify it very slowly. Let's have a look for this ln 4, and let's have a look for 2 ln 2. Okay, so I will just want to show you here. When I'm having a ln b, I can write become ln b power a. Agree? Because the power of a can put it back, so it becomes ln b power a. Let's have a look for this denominator here, 2 ln 2. So 2 ln 2, what does it mean? It means that you can make it back become ln 2 squared. And what's the value for 2 squared here? You're having ln 4. And you were aware that this 2 ln 2 and ln 4 is basically having the same value. That's why you can simplify it first. Okay, Alright, so I think this one no problem, right? Okay, so what do I have here now is I'm having negative 1 over 2e 2y equals to 1 minus e power 1, then minus half. Okay, then 1 minus half, I get a half. So I'm having half minus e power 1. I just want to keep the y on the left hand side. So what can I do next is I multiply the whole equation by a 2 so that I get rid of the denominator of 2 first. And I will be having negative 1 e power 2y. Half multiply with 2, you get a 1. Then this one multiply with 2, you get 2e power 1. Okay, and now I want to move the e power 2y to the right hand side and this whole thing to the left because I want to have everything in terms of y, right? So I will be having e 2y equals to negative 1 over 1 minus 2e power 1. I'm trying to make it very detailed so that you roughly know how I get to the final answer, okay? So I hope that you have the idea what am I doing here. Yeah? Alright, so again, this negative on top, I don't like it to be in this way. So what I want to do is I want to multiply this negative in the bracket for both terms. Negative here, negative inside the second term, alright? And now, if I try to rewrite again, I'm having e power 2y equals to 1 over 2e power 1 minus the 1. Okay, then y, I want to take it down. I take ln for both sides, then I pull the power in front. Therefore, I'm having 2y ln e equals to ln 1 over 2e power 1 minus 1. Ln e value is a 1, right? This value basically is a 1. This is a 1. Then to keep only the y on the left-hand side, I will be having 1 over 2. Then ln 1 over 2e power 1 minus 1. Yeah, so I think this is what I get for the y. And then I am not going to change it become a long decimal number whatsoever or simplify further because I just want to keep it in the exact value. So this is the exact value for the y. Okay, so the step is a bit long. I show it a bit too detailed. Okay, a bit very detailed. So just make sure that you know what am I doing here. So you can just slowly simplify, move everything to one side and get the value for the y. Alright, so this is how we solve question number 9. Sorry, this is question number 8. Okay, question number 9. By sketching a suitable pair of graphs, show this equation has only one root in this particular interval. Alright, so when they want us to sketch a suitable pair, that means you need to draw two graphs, right? A pair of graphs. And what are we going to do is, I'm going to separate into two parts. The first curve will be this one, y equals to secant 2x. Then another one that I'm going to sketch is this part where it is y equals to negative e power x. Alright, so let's start with y equals to secant 2x first. Secant 2x coming from the original graph of cos x because secant 2x is 1 over cos x. So usually for me what I'm doing here is I try to draw the original graph of cos x first. This is the cos x. I'm having 0, then pi over 2, okay, then pi, 3 pi over 2 and 2 pi. This is the original graph for cos x. But if I want to apply a stretch in x direction, right? So that means when I'm having a 2 inside the basic function x, then basically all the value of x I have to multiply with half. So when I multiply with half, 0 remain as 0, pi over 2, okay, so pi over 2 divide by half. What do I have here? I should be having pi over 4, right? So multiply with half, you're having this as pi over 4. Okay, then for the pi here, if I divide it by 2, I'll be having pi over 2. And for me, in my question, they only request us to draw this one. The domain that we are considering is 0 to pi over 2. So after I multiply the x coordinate with half, I got my graph pi over 2 until this part. So that means I want to consider my graph until this part only for the cos 2x. Okay, between the domain of 0 until half. Pi over 2, sorry. Okay, so this is the cos 2x. And if this is cos 2x, when I want to draw and make it become 1 over cos 2x, then basically you need to know some important values here. When you are having the value of y equals to 0, okay, that means in your 1 over cos 2x, it will become the asymptote. When your value of y equals to 0, because if you want to draw y equals to 1 over cos 2x, right? Okay, when originally your value of the y is equal to 0, 1 divided by 0, you get infinity, which is a math error. So math error means that you are going to change this particular point into the asymptote, this particular line, which is pi over 4. Okay, minimum, this is the maximum point will become minimum. So it will continue to go upward. Alright, so for this part of the graph, I'm having it as a 1 here, then you'll keep going upward. Alright, then after that at pi over 2, it will become a, this originally is minimum point, it will become a maximum point. So that means that at pi over 2, I'm having a maximum point here, so your graph should go upward like that. And this is the cos, 1 over cos 2x, which is the secant 2x graph, between 0 until pi over 2. Right? And this is basically how I always remember how to sketch the secant 2x graph. Of course, some students, they prefer to memorize everything. So if you're able to memorize the graph, then of course you can go ahead with it. Right? Yeah, so this is a graph for secant 2x. And now I want to sketch negative e power x. Alright, so first of all, I try to sketch e power x first. E power x will look something like this. And the y-intercept is a 1. This is e power x. When you multiply a negative in front of the e power x, it is a reflection in the x-axis. That means it is an up-down reflection. So if you try to sketch a diagram, it will become something like this, where it will cut through the negative 1, and this is a graph for y equals to negative e to x. Alright, so if I try to combine these two graphs together, and my graph should look something like this. Okay, so maybe I try to label it first. I label this as pi over 4. Okay, then I'm having a pi over 2 here. This is the pi over 2. Alright, okay, so I'm having a minimum point at 1, then going upward. Okay, then I'm having a maximum point at pi over 2, and then actually also going upward from the negative infinity. So this red color line will be what we have for y equals to secant 2x. And after that, I want to bring in my negative e power x. Negative e power x will look something like this. Okay, so it should be a curve, and then this is a value negative 1. So this purple color one will be y equals to negative e power x. Alright, so we have to try to label our graph clearly. And after that, let us make the conclusion. So they want us to prove that there's only one root in this interval. So what's the meaning for one root? One root means that you can only see one intersection point in the graph that you draw. So what you can do is that you can tell them the conclusion. One intersection point can be seen. Hence, there's only one root in the particular interval here. Alright, so this is what we have for part A in question number 9. And let's proceed to part B. They want you to show by calculation that this root lies between 0.9 and also the 1. And usually for me, when I want to prove that my root lies between two values, the method that I'm using is sign change method. So for sign change method is, I will try to rephrase my equation here become a function. Alright, so if I rephrase it become a function, that basically I'm having fx equals to secant 2x, then plus e power x. Right, then to prove that the root is between these two values, I need to substitute the value inside the function, and I must get a sign change between these two values. I must get a sign change, that means one positive value and one negative value, to prove that we are having the root between these two numbers here, 0.9 and also the 1. Okay, so we can press calculator for this. Alright, so let's have a look here. Secant 2x means 1 over cos x. Alright, so I have to press 1, then cos, then 2x. Okay, wait me for a moment, yeah. Cos 2x. Right, so that's secant 2x, then plus e power x. So e power x. And then please take note that when we are pressing the calculator, right, this question, because we are having something that involve the trigo. And when we calculate anything about the trigo, in all this kind of question, you need to be aware that our x are all measured in radian, in the unit of radian. Therefore, when you want to press calculator also, please make sure you change your unit or the mode of your calculator into radian. So you should see a small r here. Then only you try to calculate. Now I will substitute the value of 0.9. Then you press equal sign. You get negative 1.94. So I'm having this value here, secant 2 times 0.9, then plus e power 0.9. The particular value that I get here is negative 1.94, correct to 3 significant figure. Then after that, I do the same thing, substitute the 1, press calculate, press a 1, equal sign. Then I get 0.315, so 0.315. And if you compare these two values, right, you can see very clearly that this is a negative value and this is a positive value. Therefore, we can make a conclusion that the root lies between 0.9 and 1. So I will usually write out the observation or the reason. So sign change can be seen between f0.9 and also f1. Okay, so hence the root lies between 0.9 and also the 1. Okay, this is what we have for part B. And let's continue to have a look for part C. For part C, they want us to show that if a sequence of values given by the iterative formula converge, then it converges to the root of the equation in part A. So that means they are asking us to prove that this equation, right, basically if you rephrase it, can get the original equation for part A. So that's the meaning of it, alright? So it's quite simple and straightforward. What you can do is you can prove this one, start from here, rewrite it and rearrange it to get the original equation, which is secant 2x equals to negative e power x. Or you can do it the other way around. You can start from the part A and get it back to the part B. Okay, so it depends on how you look at the question. Usually for me, both directions also can. You can just choose only one. Alright, so I'm having secant 2x equals to negative e power x. This is the original equation that I have in part A. Alright, so I'm going to do it slowly. From my answer here, I can observe the cos. So I try to change my secant 2x become something with the cos first. Alright, then if I want to take the cos inverse, I have to make sure that the cos is a numerator or maybe not a denominator. So I try to move this cos x up. I will be having 1 over negative e power x, then equals to cos 2x. Alright, then when I rephrase this particular term, I will be having, you bring the denominator up, right, become numerator. So that means your power has a negative sign now. So you're having negative e, negative x. And from here, you can see that now they are having cos inverse. So that means I take the cos inverse over. I will be having cos inverse negative e power negative x, followed by bringing the 2 over, it will become divided 2. So this is what I have. And we successfully prove from the equation in part A and get this iterative formula. Okay, yeah. So some student found that, if you start from here and prove back to this one is easier. So up to you. You can start from any direction. You can complete this question in any direction. Right. Okay, so this is what you have for part C. Then let's continue to part D. Alright, so for part D, use the iterative formula given in part C to calculate x correct to 3 decimal places. Okay, so your final answer must be in 3 decimal places. Give the result of each iteration to 5 decimal places. And now we want to apply our iterative process. So what is the iteration formula? Basically, this is the iteration formula for the iterative formula. Alright, so we are having x equals to half, then cos inverse, negative e power negative x. Alright, So when we want to get all the iteration value here, I can use calculator to help me. But before that, of course, I have to key in the formula first. Okay, so as a formula for iterative formula, it will be the right-hand side of this equation, this part. So we need to key in this equation in our calculator. We are having half, so I put it as a 2 at the bottom. Then on top here, I'm having cos inverse, so cos inverse again. Then negative e power negative x, so negative e power negative x. Then close bracket. Okay, all right. Then again, when you want to press any value for this equation, right, because you can see that the cos, the trigo is involved in the calculation, please make sure that your calculator are in the radian mode. Must be in radian mode. Yeah? If you put degree, definitely your answer is wrong one, because all the value that you put in refer to the radian unit, all right? Okay, so let us start with the initial value. For this question, they didn't give me any initial value. You can always use any value that you like. And for me, I usually will tell students, you can always refer back to your sign change value here. All right, yeah, so like our sign change value just now. So sign change, that just now they said that the root is between 0.9 and also the 1, right? Yeah, so you can use any value lah that you like between 0.9 and 1. Okay, can be anything. But of course, some students say that, how about if let's say I use a value outside the range, outside this 0.9 and 1, can I still get an answer? So the answer is yes, you can still get the answer 1. All right, but I will strongly suggest you don't be too far away from what you have there. Okay, all right. And then let us start. So for this video, I'll show you one example. I purposely don't use the value that's within the 0.9 and 1. I'm trying to start with 0.8, let's say. Okay, but this 0.8, okay, so this 0.8 is not too far away from 0.9 and 1, right? Yeah. So this is just to show you that eventually I can still get answer. All right. Yeah. So if let's say you want, then you can just use a 0.9 or 0.95 or 1, up to you. Usually I will just take that two value as a reference point, the reference value to start with. Okay. Right. Okay. So we start. Let's say now I want to use the 0.8. Okay. How to get the x2? So to get the x2, you need to substitute the 0.8 into your equation here, the iterative equation. So I'm having negative e power negative 0.8. Then you can use calculator to help you and press it. Okay, so just now I have key in the formula here, right? So I just need to press calculate, then key in the value 0.8 and press equal sign. So you get this value here, 1.018405196, a very long value. We'll put it into 5 decimal places, right? So for 5 decimal places, I have 1.01841. So 1.01841. Okay, then after that, I want to get the next value here. So to get the next value here, same thing happen. Substitute 1.01841 into my iterative formula. Okay, so it's like we're repeating the process. So press calculate again. Key in the value of 1.01841. Then press equal sign. And you get 0.97016. 0.97016. Agree? All right, then let's continue further. Okay, repeat the process again. So press calculate. Key in the value 0.97016. Then press equal sign. Then you get this value here. Rewrite it again. So 0.97977. Okay, so a lot of students will ask, when should I stop the process? And we will stop the process if you successfully get the repeated same value for 3 decimal places. As an example, for the first one, this one, if you correct it to 3 decimal places, it is 1.018. This one will be 0.970. Are these two values the same in 3 decimal places? No, right? So that means you have to continue to repeat until you get the same value. Right? So for the x4, if you correct it to 3 decimal places, your answer should be 0.980. Also still different from the previous one. Then you have to repeat until you get the same value. Alright. Okay. Then let's continue further. I press calculate again. Now key in 0.97977. Then press equal sign. you get 97781. So 0.97781. Correct it to 3 decimal places, you're having 0.978. Are they repeating already? Not yet, right? So that means please continue further. Alright, okay, then let's continue. Key in, calculate. Key in the value of 97781. Then press equal sign. 97821. 97821. Alright, then if I double check for this value, you are getting 0.978. So you can see that they are repeated here. Alright, if you want it to be safe, of course you can try for one more iterative lah, just to make sure and double confirm that this is the final answer already. So let's continue further. Calculate 0.97821. Then press equal sign. You'll get 97813. So 0.97813. Double check it with the 3 decimal places answer. It is 0.978. So it means that we are confirmed the root will be equals to this 3 decimal places answer, which is 0.978. Alright, so when you want to write out your iterations, right, please make sure that you write out all of them in 5 decimal places according to what is requested in the question. Right. Then you can see that I'm trying to write out everything in 5 decimal places. Then we can stop when you get the repeated 3 decimal places answer. Alright, so this is the process of applying iterations, applying the iterative formula to get the root. Alright, so this is how we answer question number 9. Alright, so question number 10. We are having a function, then they want us to express this function in partial fraction. Alright, so before we start, let us have a look and see, do we have proper fraction or improper fraction first? Okay, the highest degree in numerator is 3. This is degree equals to 3. Okay, when you multiply all the x together in the denominator, you are having also x power 3. It also tells you that it is degree 3. When you're having the same degree of numerator, the degree of numerator is the same or greater than the denominator, then we are having the improper fraction. And for improper fraction, before you can split it into the partial fraction, you need to apply long division first. Okay, alright, so this is what we need to do lah. So first of all, we have to apply long division to change this improper fraction become proper fraction first. After that, only we can use the remainder in the long division to apply partial fraction. Alright, okay, so let us start. Before we start, right, of course, we need to know what is the divisor or factor in this case. This is a divisor. You need to expand it first. Okay, so if you try to expand it and you get x power 3 plus 3x squared plus 2x plus 6. That means when you want to apply the long division, this is what you have. X power 3 plus 0x squared plus 2x minus 11. And I'm having the divisor x power 3 plus 3x squared plus 2x plus 6. Okay, so plus 6. Okay, so we apply the long division here. Something multiplied with x power 3 to get x power 3. So the something here should be a 1. So 1 multiplied with x power 3. Then you get 1 multiplied with 3x squared. 1 multiplied with 2x. 1 multiplied with a 6. Okay. And after that, I have to take the term on top minus the term at the bottom. So I'm having negative 3x squared. This one becomes 0. Then negative 11 minus 6, we are having negative 17. Therefore, this negative 3x squared and negative 17 will be the remainder that you want to use and put it here. Alright? Okay, so let us have a look. Yeah, how can we rephrase this whole thing here? Basically, when I'm having polynomial, the general formula is equals to divisor multiply with quotient plus remainder. Okay, and now I'm having it as a fraction where I'm having the polynomial divided by the divisor now. If I divide everything by the divisor, then I'm having the quotient. Quotient divisor divided by divisor is quotient, right? So I'm having the quotient plus remainder over divisor. So if I want to apply what I have in this is my px on top, dx at the bottom. So if I write it out, my equation will look something like this. X power 3 plus 2x minus 11 divided by, this is the divisor, okay, will be equals to quotient. So what's my quotient? Quotient is this one, 1. Then plus remainder. What's my remainder? Negative 3x squared minus 17 divided by the divisor again. So x plus 3, then 2 plus x squared. Alright, then if I want to continue and figure out the partial fraction, I should only focus on this part. Because this is the proper fraction that I have, then only I can continue to split it become partial fraction. Okay, so for this part, I'm going to show you the step at the bottom. I can further expand it, become a smaller fraction now, which is the partial fraction. Right, so let's start here. I'm having negative 3x squared minus 17 divided by the factor or divisor 3 plus x and also 2 plus x squared. Okay, so for this one, I'm having one linear factor at the denominator, one quadratic factor at the denominator. So I will be having a over x plus 3 or 3 plus x. Then for the quadratic factor, if I want to expand it, right, I will be having the x with 1 degree lower. So I need to start my numerator with bx power 1 followed by plus c. Okay, multiply this whole equation by using this original denominator here so that I can get rid of the denominator. And this is what I will get after I simplify it. Alright, then now I need to try and figure out what's the value for A, what's the value for B, and also the C. Alright, so first step, I want to make the bracket 3 plus x become 0. Because I know that if I make this become 0, 0 multiplied with this whole thing also 0. That means you can directly find out the A later. Okay, so how can I make this bracket become 0? You need to let x equals to negative 3. Okay, so if you let x equals to negative 3, then this value that you get here will be negative 44 equals to 0 multiplied with anything also 0, but 2 plus 0 square, this is 0, my 0 plus anything becomes 0. But if you substitute negative 3 here, so negative 3 square is a 9. 9 plus 2 is 11, so you're having 11a. Then very easily you'll get a value of a, which is equals to negative 4. Right, then for the second value, this is a quadratic factor. I can't make it become 0, 1. Okay, so what I want to consider is maybe this one, bx. I will let x equals to 0 so that the b disappear. When x is equals to 0, substitute x equals 0 here, you will get a negative 17. So 2 plus 0 is a 2, but 2 multiplied with negative 4 that you calculate just now is negative 8 plus 0b. What's the value of c? We don't know, but you're having a 3 plus 0 here, which is 3c. Then again, very easily also, you can get the value of the c from this equation, and by right, it should be negative 3. Okay? Then after that, there's no more value of x that I can make it become 0, or maybe there's no bracket that I can make it become 0 anymore. In this case, you can use any value that you like, but you never used before one. So as an example, I use x equals to 1. Okay? I never use x equals to 1 here, right? So I directly use x equals to 1. Substitute the 1 here. What do you get here will be a negative of 20 equals to negative 1, positive 1. 1 square is a 1, 3a. 3a means negative 12. Plus, substitute 1 inside the b, bx, the x beside the b. So you're having the b plus c is minus 3 because c is negative 3 just now. Then 3 plus 0 means 3 plus 1 is a 4. Okay, then if I try to simplify this particular equation, by right I'll be having b equals to 1. So that means according to what we have here, a is negative 4, b is 1, c is negative 3. And usually for me, I will rewrite everything one more time again, which is x power 3 plus 2x minus 11 divided by 3 plus x, 2 plus x squared, okay, equals to, originally this is the quotient 1, then plus the remainder. So this one I successfully expand it become these two, right? So what will it be? It will be negative 4 over 3 plus x. Then plus b is a 1, so you're having the x. C is negative 3, so negative 3 divided by 2 plus x squared. So this is a final version or final answer for the partial fraction that involve improper fraction. So for improper fraction, every time you will see that you need to apply a long division to get a quotient first, or simplify your fraction to make it become there's a number here. All right. Okay. Can So this is what you have for part 8 in question number 10. Then let's continue to part number B in question number 10. Now they want you to obtain the expansion of fx in ascending power of x up to and including the term in x squared. Okay, so when they want us to expand this one, okay, so let me copy it back here. This is what you have. And I want to use this answer and make it okay, so they want us to make this expression into the pattern here in ascending power of x up to and including x squared. To get something in polynomial like x squared whatsoever, this kind of question, basically have to apply binomial expansion. Alright, so binomial expansion formula is provided in the formula booklet, but for me, I will just write it again here so that it's easier for us to refer. Binomial expansion. What should I have here, yeah? Okay, so to apply the binomial expansion in A2 syllabus, our power can be positive or negative rational number, right? Okay, then to apply this binomial expansion formula, I have to make sure that my first term in the bracket starting with a 1. It must be a 1, yeah? And then power n. First term is always a 1. Second term is always an x. The third one is n minus 1, divided by 2 factorial with x squared. I will stop at x squared here because of the question requested only up to x squared. Alright? Okay, then now we have to continue from this particular phrase, yeah? Because this one, if you want to apply binomial expansion, can, but it is a bit more complicated. To me, I feel, right? When you multiply these two brackets together at the denominator, I feel that the steps will be a bit more complicated because you consider all the multiplication later. So what I do is I directly start from this part. Okay? 1 is a constant, so I don't need to do anything. If I bring the power 3 plus x up, it will become 3 plus x power negative 1. X minus 3 remain as the numerator, don't touch it. But I want to move up the 2 plus x squared, it will become 2 plus x squared power negative 1. Okay? Then like what I told you just now, when you want to use the binomial expansion and expand your equation, for our steps here, I need to expand this one, this bracket with power negative 1. I also need to expand this bracket with the power negative 1. Okay, but before that, like what I told you, our rules to apply the formula is you have to make sure that the first term in the bracket start with 1. So I need to take out the 3. I need to take out the 3 from the bracket, so don't forget about the power. After you take out the 3, right, it will become the 1. Then the x, to make it balance, you have to divide it by 3. Because later, if you multiply the 3, go back, you'll get back the x. Right, so this is power negative 1. Okay, same thing happened here. X minus 3, I don't need to do anything because it is a numerator. But when I'm having a power of negative 1, I need to expand, apply binomial expansion formula here. But again, I have to make sure that my first term start with 1. So what I do is that I need to take out the 2. When I take out the 2, what do I have here is 2 power negative 1 with the 1 plus x squared. Don't forget to divide the 2 for the x squared. After you take out the 2, you have to divide the second term by 2. Okay? Right. So now for this step is, you are seeing that I try to get all my bracket here start with the first term with a 1. Okay. Right. Then again, for 3 power negative 1 means divided lah. So divided by 3. So 4 divided by 3. Alright. Okay, then for this particular bracket, I want to apply the binomial expansion now. Okay, I put it in blue color. So you can see that this number multiply with the binomial expansion. So for me, I put a big bracket here, a square bracket. First term is a 1, so just copy it with a 1. Second term is n times x. What's your n? N is negative 1. Your x is the second term in your bracket, which is x over 3. So this is nx. Then the third step is, the third term is n and n minus 1. So I'm having negative 1, then negative 2, divided by 2 factorial with x squared. So the second term in the bracket with a square. Then personally, I will stop here because for this question, they request us to expand until x squared only. So the blue color part, after the expansion, this is what we have. Okay, then follow the next. I'm having 2 power negative 1 with x minus 3. So what I do here is I just take plus half with the x minus 3. And now I want to expand this bracket. Okay, so I want to expand this particular bracket with a power negative 1 by using purple color. Right. So again, how do I expand it? Still follow the binomial expansion formula. First term is always a 1. Second term is nx. So my n is negative 1. X is the second term in the bracket, which is x squared over 2. And for this bracket, I'm not going to continue anymore because I successfully get x squared already. If I continue further for the third one, then I'm having x squared, right? So I'm having this term, then I square it become x power 4. So there's no need for us to do something that is not needed later. Right? So for me, I'll just stop here. Okay? Alright. Then next, let's do it slowly again. When we go back to our step here, try to simplify all the terms in your binomial expansion carefully. Okay, I still put it in blue color so that you can refer it clearly. So if you simplify it using calculator without any error, this blue color part will give you this answer when you simplify them. Okay, then after that, for the purple color one, I also want to simplify it. First, I will be having 1 minus x squared over 2. Okay, yeah, so everything seems like quite smooth. Then let us group all the terms with the same pattern together. Okay, before you can group all the terms together, multiply the constant here to every single term in your expansion just now. Yeah, alright. So I'm having 1 minus 4 over 3 plus 4 over 9x. Okay, then minus 4 over 27x squared. Alright, so just make sure that you double check and make sure there's no careless mistake lah. Alright, then plus. Okay, for the second part here, need to be more careful because you need to expand everything. X multiplied with 1, you get an x. X multiplied with x squared, you get x cubed, right? So for this x cubed, I don't consider it in my expansion, so I don't write it out. Alright, so from here, I'm having half. When you expand this bracket, what do you have here is x. Then you need to consider this one. Negative 3 times 1, you have negative 3. Then the negative 3 multiplied with this one, you'll get something with the x squared, right? So I'll just continue with this plus 3 over 2x squared. If I don't do any careless mistake. Okay, right. Then next one. Again, I can of course simplify my answer, but again, I need to make sure that I multiply the half into the bracket first. Okay, if I multiply the half inside, this is what I get. Okay, then after that, I think this step onwards, you should know how to do it, right? Please group all the pure number all together, 1 minus 4 over 3 minus 3 over 2. So if you simplify all this without any careless mistake, by right, you should be getting negatives 11 over 6. Then try to group all the term with x power 1 all together. So there are two terms here. By right, you should be having 17 over 18x. Then lastly, group all the x squared term together. Then from that, what do you get here is 65 over 108 with x squared. Yeah, so this is what we call as a binomial expansion from a partial fraction. Okay, although when we write the steps, it looks so complicated or maybe so hard to understand, but basically this question is comparatively straightforward because you just apply the formula. Okay, just that when you are trying to simplify your answer, make sure that you don't do careless mistake will do. Yeah, alright, so this is how we answer the question number. Alright, so we are now at the very last question for this paper, question 11. We are given the position vector for 4 different points here, point A, point B, C, and D. Then they are saying that the line M pass through the point A and B. So if we try to imagine, if let's say I'm having the line M here, it passed through point A, it passed through point B. Okay, so find a vector equation for the M. Alright, so to find the vector equation, just like when you want to find the equation of a linear graph, we basically need the gradient and also a passing point. Gradient and passing point, alright? Okay, so same thing happens for vector equation. I also need the gradient. But the gradient in the vector equation is direction of the line. So the direction of the line means that you can try to figure out what is AB or what is BA because the line passed through A and B, right? So the direction will be either BA or BA lah. The direction will be parallel to the line AB or BA. So this is my gradient of the line where I call as a vector, the direction of the line. Okay, for me personally, I find out the AB. AB means AO plus OB. AO is -1, -5, -3. OB is 0, 4, 1. Then what do I get here when I simplify is -1, -1, and also -2. Okay, then I have my gradient of the line already, which is the direction of the line. Do I have passing point or not for this particular line? I have more than one passing point. Passing point A or passing point B. So in the vector equation, you can use any of these passing point lah. General formula for forming a vector equation is R equals to A plus dB, where A is the passing point, then P is the direction of the line. So if I substitute my value in, passing point, I'm using the point B lah, right? I prefer to use a point with the 0, 1. So I will be having 0, 4, 1 plus T, and then what is the P? P is -1, -1, and also -2. But all the three negative here, right? I can factorize out the negative and put it together with the T. T multiplied with -1 still a constant, so still a T. So usually what I do is like I will not write out the negative. I assume that I have factorized out the negative, then I put it together with the T. Therefore, I'm having a 1, 1, 2 here. And this is the vector equation for the line M. Right, so let's continue to part B. Find the position vector of the point of intersection M and the line passing through the points C and D. Alright, so that means you need to find the intersection point between line M and the other line, which is CD lah. So same thing happen here. If you already have the point M, the line M, then maybe you have another point that pass through the C and D. You need to find the intersection point, right? Yeah, so to find the intersection point, you need to solve the equation simultaneously. But I already have the equation for AB only, but I don't have the equation for CD. So same thing happen here. I try to find out the direction of the line CD, which is CD. It will be CO plus OD. So what is the CO here? Make it smaller. CO. CO is -1, 3, and -1. then plus OD. What is your OD? OD is this one, 3, -5, and also the 4. And the direction of this particular line will be what? It will be 2, -2, and also 3. And again, this is the direction of the line CD, and the passing point for the line CD is either the point C or point D. So again, I will write out the vector equation for the line CD. It should be equals to R, A plus TP. The A is the passing point. You can use any passing point that you like. I'm using the passing point C here. Plus, I use lambda now, I don't use the T, so that they know that these are two different values. So I use lambda here. So lambda, the direction is 2, -2, and also the 3. Okay, then to find out the intersection point, I need to solve two linear equations simultaneously, right? So same thing happens for vector equation. To find the intersection point between these two lines, I need to solve the vector equation simultaneously. So I will let this one equals to this one, okay? All right, so let's start. So for this part, I'm using blue color, yeah, so that you know that I'm trying to solve it. All right, so I'm having the first part of the equation is this one, the first vector equation. I'm having 1 plus t, I'm having 0 plus t, 4 plus t, then 1 plus 2t. Okay, so 0 plus t, 4 plus t, and after that 1 plus 2t. Equals to my second equation here. What is my second equation here? The vector equation is this one, where I'm having 1 plus 2 lambda, -3 minus 2 lambda, and also 1 plus 3 lambda. Okay, so from here, I will compare the x coordinate with the x coordinate. From this part, I'll be getting my first equation, t equals to 1 plus 2 lambda. Okay, then after that, my second equation will be this one. You can use any equation that you like. So for me personally, I'm using maybe this one. 4 plus t equals to this. So I have 4 plus t equals to -3 minus 2 lambda. And this is my second equation. I want to solve them simultaneously to get the value of t or the lambda also can. Alright, okay, substitute equation number 1 into equation number 2. So what do I have here is 4 plus t. T is 1 plus 2 lambda. Okay, then I try to simplify them. And my lambda here is equals to -2. Alright, then once I get my lambda equals to -2, to get the intersection point, I directly substitute this into my vector equation to get the position vector of the intersection point. Okay, so let's write out the position vector directly. Position vector of intersection point. So what will it be? Okay, so substitute -2 inside this part. 1 minus 4. So 1 minus 4 is -3. Then this is the x coordinate, so we put it as an I. -2 substitute in here, you'll be having -3 plus 4, right? So -3 plus 4 is a +1, so plus 1j. Then -2 substitute in here, you'll be having -6 plus 1, which is -5. So this particular vector will be the intersection point, the coordinate for the intersection point, or the position vector for the intersection point between the two lines. Okay, yeah, so this is how we get the intersection point, all right? Okay, then how about for part C? Okay, part C, now they said find the position vector of the foot of the perpendicular from C to M. Okay, so let's say I redraw my line again. I'm having the line M. It passed through the A and also passed through the B. Okay, then I have the point C. This is my point C. What's the meaning of the foot of perpendicular from C to M? So that means when I have a perpendicular distance from C to M, which is the 90-degree one, okay, so this particular point is the foot of perpendicular. And I will usually label it as F. Okay, the foot of perpendicular. They want us to find the position vector for this foot of perpendicular. Okay, all right. Since we know that the point lies on the line M, so I want to recall back what is the equation of line M that we have. So for line M, we are having R equals to 0, 4, 1 plus T, then 1, 1, 2. This is what I have for line M, right? Since the F falls on the line or lies on the line M, therefore you should know that the position vector of F basically is the same as what we have in this vector equation. So I will write OF as T, then 4 plus T, and also 1 plus 2T. I'll make it bigger. Okay, I'm having T, then 4 plus T, then 1 plus 2T. Okay, right, so this is my OF. And now I want to use some common sense. Okay, there's a series of the process, right? But all these are some common sense by using the perpendicular knowledge to solve it. There are many ways to solve this question. Basically, some students might use the product rule or whatsoever. There are a lot. Okay, for me, I'm just using some a few steps that is related to the perpendicular to solve for it. All right. Okay. So first step, what I do is that I write out the position vector for the F first. Okay. So this is what we have. But I don't want my answer in terms of T1. I want to get the value of T so that I can substitute it and get the position vector of the F. This is what I want to find. Okay. Right. So if I have a look for the diagram here, basically you know that the direction CF is perpendicular to direction AB, right? So let me find out the CF first. So what is CF? CO plus OF. What is CO? CO is -1, 3, and -1. What is OF? This is what we have for the OF here. Okay, and if I simplify them, what do I have here is -1 plus T, 7 plus T, then -1 plus 1 becomes 0, so I'm having a 2T. This is the CF. Okay, that's CF perpendicular to AB. So I know that CF, these two directions, right? CF perpendicular to AB, right? So what does it mean? It means that we should know that when I take the vector CF dot product with the vector AB, it should be equals to 0. So we learned about this property in vector. Okay, when the two vectors, they are perpendicular to each other, then the dot product of these two vectors should be equals to 0. Okay, I have my CF here, which is -1 plus T, 7 plus T, and also 2T. Dot product with the AB. What's my AB just now? I have found it out in first part just now. -1, -1, and also -2. Then we let it equals to 0. Okay, so try to substitute it into the equation. So dot product means that you are taking x multiplied with the x. So what do I have here? I'm having 1 minus t. Then plus y multiplied with the y. So y multiplied with the y, you'll be having -7, negative t, right? So you write -7, negative t. Then last one, you are having z multiplied with the z. So you're having -4t. Then you let it equals to 0. Okay, then we just try to simplify this answer. I'm having -6t. Then 1 minus 7 is -6, right? Bring it over, become +6. Therefore, the t that I get here is a -1. Okay? Then when I get the value of t, which is -1, so what can I do here is, I will try to substitute it back into the equation. Okay, all right. So to get the OF, this is what I have for OF, yeah? So substitute the T, go back to the OF. Therefore, what's the OF that I have? Okay, so t is negative 1. 4 minus 1, you get 3. 1 minus 2, you get negative 1. Okay, you can write in a vector form like this for OF, or if you don't want, you can write into the ijk form. So negative 1i plus 3j, then negative k. Okay, right. So this is basically how I find out the position vector of foot of the perpendicular line. Alright, I didn't use the formula directly from some maybe from some summary or whatever, but I'm trying to find out the value of t just using some very basic idea on the perpendicular vectors, okay, and solve for the t. Alright. Okay, so basically this is the end of the video, and thank you very much for watching this